Wonderful. So what we're doing now is we're kind of opening up the discussion. And so for people who are listening, this is where we just now talk with each other. We've heard some fascinating presentations. And what I'm likely to do is that this part of the discussion will be for 30 minutes. I will then do a formal close of the conference. So I'll do the outro, but I'll ask anybody who can stay further for us to continue to talk afterwards. And that's for the audience. And we'll take some questions and so on if I can, if you put them in. So anybody wants to go first. I just wanted to say the Carla, the work that you have done with regards to the bacterial involvement in terms of infection is a game changer. I can, that's all I can say, is that it adds so much to the understanding of the disease. What made you think of doing that?
The toxins. So at the beginning, we didn't realize that bacteria was was a cofactor in this disease. And when we found the toxins in the plasma of COVID-19 patients, and we observed the mass spectrometry of each toxin, we noted the variation of amino acidic. Every time the conotoxin was presented more time in the same patients with every time an amino acidic variation. Every time 10 times, 20 times, 30 times. So when I look at this amino acidic variation, I remember of polycistronic mechanism of bacteria. And I asked me, why these toxins have variation so frequent? And maybe the bacteria produce them. So we performed the culture to found the toxin production in the fecal bacterial culture after 30 days. And the control of RNA increase was only internal control. We don't think we didn't think the bacteriophage mechanism. It was a very è stato un caso, come dire,
coincidence case.
Was a case to found this observation. Yes.
Yes, chance observation. Wow, tremendous. And Mike, I'm just curious from your perspective with regards to the neural symptoms, because one of the arguments has always been that the virus is continuing to replicate in brain tissue, and this is what's driving the symptoms. Any thoughts with how what you are looking at from a neural perspective could tie in with what Carlo is seeing?
I mean, if the virus had penetrated into brain and was replicating, that certainly could be an explanation. But I don't think that has to be the case for there to be neural consequences at all. So peripheral inflammation can drive excitation towards the brain. So, vagus nerve to brainstem, and then it triggers what's called a mirror response on the brain side of the blood-brain barrier, where glia activate. And the activated glia kind of act like amplifiers. So that can be on stress-related circuitry, triggering depression. If someone's got some vulnerability to different forms of psychopathology, that could, drive those problems. So I don't think it has to be the case that it's virus in brain. That certainly would be bad news if that were happening. But I don't think it has to be for there to be really profound neurological consequences if inflammation or problems with vasculature were driving it.
Great. Joachim, go ahead. You wanted a question? You're muted at the moment.
So sorry. One question to Mike, a quick one. We are just finishing trials in animal trials in India on our phenolic compounds, the mix of these flavonoids and compounds on M1, M2 state macrophages. And we have seen already the results that it is helping to stop this activation. Would that also theoretically work on glia?
Yeah, I mean, microglia are the resident macrophages of the brain. So during development, macrophages form in the yolk sac, and then during development, they sort of move to different areas of the body and take up residency. So there's resident macrophages all over the body, in the endometriosal tissue all over. And in the brain, the resident macrophages are just the microglia. So something that works on microglia, if it has brain penetrance, would probably affect the microglia as well.
I'll share that with you then, and then we have a look at it. Thank you.
Great. Manan, go ahead.
Yeah. I was so much tempted, when Carlos was presenting, that I was wishing that if I would be the panelist there, to ask this question, and then we will have a panel discussion. So the question is for Carlos, Dr. Carlos, thank you very much for your very nice presentation. What I was wondering is that there are two bits to my question. Number one is that if the bacteria in the gut are actually harboring the virus, do you think that the toxins that they are releasing could escape to portal vein and liver and into the blood, and they could be contributing to the sign and symptoms of long COVID? What are your thoughts on that?
Ma che cosa ha detto? Ok.
Ha detto, non pensi che gli elementi che stanno nella parte cerebrale possono uscire fuori uscire da un'altra parte del corpo?
Oh, yes, of course. Thank you for the question. Of course, it is possible, everything. We don't exclude nothing, and we much more study to understand the mechanism. We are providing we are make some experiment on the midges, on the midges, and we are waiting for the results. And we also are performing experiment on neuronal cell with the toxin. And but in this moment we have not the results, so I can't explain everything in the right way. But everything is possible. We don't exclude the double mechanism of SARS-CoV-2. SARS-CoV-2 obviously attaches the human cell and the epithelial cell, but in our test, in our experiments, it also attaches the bacteria. So the toxins maybe can be produced also by human cell. We can exclude everything, but we must perform more experiments. So we are at the beginning of this new way, and so it's premature to definitively. It's too early to say something on or not.
Do you think that if we develop a strategy, in which we can make keep the bacteria, not kill it, but make it vomit the virus, and then give some oral antivirals, as Dr. Leo mentioned that sometimes the antibiotic or antiviral which has less absorption from the gut is a good news, So you make the bacteria vomit, and then you give that antiviral that's not absorbed very good from the gut, that can locally kill the virus. So I'm just thinking loud, because destruction of the microbe will actually change the what you call as normal homeostasis of the body. Do you think that it would be a viable therapy?
Yes, it is possible. I can't exclude also this observation. So we have focused attention on one aspect, but we need, in reality, we need more investigated the process.
Thank you.
Can I, just before Shankara, so Shankara is going to make, and then Leo, but I'll just make a quick point to Manan. One of the things that I have been looking at carefully that can answer some of the problems that we're seeing with the microbiome issue is literally the fact that many people have a buildup of fecal matter with abnormal bacteria. If you just completely clear their bowels, almost as if you're doing a colonoscopy, you are likely to remove quite a bit and allow a rebuilding of the gut microbiome as a simple mechanism to start it. Okay, Shankara, go ahead, your question.
Philip, more of a comment. We're noticing a variety of mechanisms at play. With COVID infection, we know that we develop a robust immune response to it. And of course, we know that in certain patients, there is an inappropriate immune-mediated response that can be very destructive. And of course, now we have the evidence that Carlo has presented. We were aware of positive PCR fecal swabs, but from his work, we're seeing that it does infect bacteria in the gut itself, which causes two things or results in two things. One is that the bacteria can cause replication of this virus and cause that persistence of virus in the gut itself. And other bacteria can produce toxins. So we've got many mechanisms at play. So we can have an individual who develops robust immunity and now does not get infected with the virus, but harbors the virus in their gut. And that can, in those patients that are actually allergic, expose them to a constant allergen and result in some of the sequelae we see. So you've got an allergenic propensity, you've got an infective propensity, you also have toxins produced. So I think the mechanisms at play are multifold and dependent on the patient itself.
Yes.
Yeah.
Yes, I agree. Yeah.
Leo, go ahead.
Carlo, I have a question for you about the impact of the toxins that you're looking at on acetylcholine. It seemed as if some of these were cholinesterase inhibitors.
Che ha detto?
Erano inibitori alcune delle tossine.
Non ho capito. Wait a moment, please.
Le tossine che tu hai scoperto,
Sì.
cioè che tu stai
Sì.
trattando, possono essere considerate anche come inibitori del Covid.
Okay. Yes, it's a good observation. Yes. I think that the bacteria produce the toxin. I show you a slide, the number 23, where in one culture where we remove SARS-CoV-2 after that they touched the bacteria continue to produce the toxin and the viral load of SARS-CoV-2 decrease. So maybe the toxin are a mechanism in our mind, a mechanism to yes. In the next picture. No. The first. Also, okay. So the sample C is the sample where SARS-CoV-2. This sample C is the sample where the supernatant of SARS-CoV-2 was removed. But the level toxin is the same of the sample A and the sample B. In the sample C, the viral load decreased very quickly. So, but not at the point 0. It continued to be still a little present. So, in our opinion, but we must more study, in our opinion, the toxins are a mechanism to destroy the virus.
So you mean it's a response by the bacteria to try and control the bacteriophage?
Yes.
So then the toxin, this will tie in, Leo, with what you are seeing, because you are noticing particular patterns of bacterial growth. So dependent on which bacteria are in, I guess, in the primary numbers, will determine potentially which toxins are produced and therefore what effects it could have on the body. So in effect, we're looking at a microbiome disease.
Yes, I think that it's very likely that the impact of the bacteriophage on the specific bacterial species may depend on the characteristics of the bacterium just as much as it does on the characteristics of the virus. Has anyone ever seen or have any experience with a virus that can act as a bacteriophage and also infect humans and other mammals?
I think I was looking at that as well, and I think one of the beta coronaviruses could do something similar. So it's not impossible, and it does happen, but not very often. This is certainly an unusual characteristic.
Yeah.
Joachim, you're going to say something? You're muted at the moment, Joachim.
Carlos has documented that well in his presentation. You can look we will share the slides anyhow between each other. So Carlos has documented that exactly the same mechanism that we see now has already been observed with other viruses. So it's not a completely new thing.
Absolutely. And it raises a question then for, I guess this is the point with the vagus nerve with regards to Mike, because as you pointed out, the vagus nerve is so well spread throughout the GI system. Could this be a mechanism for vagal stimulation, this kind of toxin impact in the gut, dysbiosis?
Yeah, and if there's gut dysbiosis that's causing inflammatory mediators to be released by the human cells, then that will be detected by the chemoreceptors on the vagus nerve afferent terminal. So, any inflammation in the trunk organs, lungs, gut, etc., would be detected and might trigger the feeling of being sick.
Mm. Yeah, go ahead, Leo.
Yeah, Mike, have you looked at low-dose naltrexone and its effects on microglial stimulation?
Yeah, it's a really interesting question because it does seem like, low-dose naltrexone is a really interesting question because you think of it as being sort of like a mu opioid effects, but it must have effects beyond that. We just need to study it better. It seems like it has some effects on natural killer cell function. There is some argument that it is a modulator of glial cells without being necessarily immunosuppressive, which I don't think you want. I wish people would study that more. It would be really good to know more about.
Are there other substances that you know of that might work as modulators of glial cell function? Curcumin, for example, that are not immune suppressive, but would control the glia.
Yeah, there's actually a lot of different things that affect glia at one point or the other. And I always think it's really important to note that if there's a way to address a root cause, you want to do that first before you go to try and affecting the glia. But given that they're that they can be primed and have problems there as well, it's something that you can address. But yes, there are, like, so for example, some even antidepressants. Antidepressant is just a marketing term, right? There's that's sort of what it's been tested for. But depression can be driven by glial activation as well. So there's a lot of different drugs. There's AV411 that's used in Japan as an anti-asthma drug. Amitriptyline is used as a glial inhibitor in some cases. There's a whole bunch. If you want to look into it, there's a good review article. The lead author on that was Peter Grace, Nature Reviews Neuroscience, maybe 2017, called Pathological Pain in the Neuroimmune Interface. People are studying, a lot of pathological pain is driven by glia pumping out neuroexcitation as well. So there's a lot of different things that are being studied.
I wanted to specifically bring in Valentina here. As we talk about some of these very complex topics with the microbiome and the neurotoxicity, what is going through the heads of the patients who have got long COVID and just want to get better?
Well, the most important thing is get treatment now. And I think it's very fair to say that 2 years on, we still don't have anything that would particularly tackle the root cause of the disease. We still are trying to understand what is happening with all these multisystemic symptoms, and people are really unhappy about the medical care they're getting. So I think this is a very unique opportunity for people to watch these videos and learn from experts who are discussing root causes and analyze lots of research papers for them to bring to their practitioners and spread the awareness about the real causes and the importance of these findings that you are discussing here today. That's number one. And number two, I think, is we are now at the stage to discuss antivirals and antibiotics, and people with long COVID cannot get the supply of antivirals because they're not within the group of disability. So they're not characterized as people in need for antivirals. And it's a huge issue for them now to basically raise awareness that long COVID is classified as a disability because many people are in bed for years with no treatment. So antivirals is very important for them now. And I just wanted to ask all of you here, what is your opinion on antivirals? Is it really the number one thing that long COVID sufferers need to take, or are there any other solutions or nutraceuticals that potentially might do the job as good as antivirals?
I'll start off with that question, Valentina, because it's a very good question, and I've heard it before with the antivirals. The only thing that I would say is that one of the difficulties, both for antivirals and antibiotics, is about how much of it remains in the gut. Because from what Carlo has demonstrated, the virus is actually replicating in fecal matter. So it's not in the systemic system, it's in the gut system. And therefore, if the antiviral is not able to concentrate well enough, is it even able to penetrate the bacteria to impact on the virus? There's so many questions about it that my suspicion would be that whilst in theory it sounds good, it may not necessarily work out in clinical practice. Any other thoughts? Manan, go ahead.
No, okay.
Yeah. So I would like to start from where Dr. Leo left us, that sometimes a decreased absorption of an antibiotic is good news, So if you are targeting gut microbes, and you come across a molecule which is not absorbed very efficiently through the gut, it might help reduce the viral load. To answer, connecting one into it, okay, is that we first have to establish that persistence of the virus is the line one cause in long COVID. If that research gets accelerated, then there are several branches, like once the persistence of the virus is there, then you can branch it into 20 to 25, what you call as subdivisions, as Dr. Leo was mentioning, that he has got a figure, cardiovascular system, renal system, pancreatic system, and then it branches out. So where it actually comes, where is the epicenter? That's the million-dollar question. You understand, Dr. Philip, you pointed out in the previous conversation that we had, that you want to go for that magic pill, isn't it? The single cause, you just catch hold of it. I would urge my community and all the persons who are involved in research to search for that pill. I mean, like, see whether the reactivation of the virus, its hiding places, like Carlos mentioned. You can't imagine the crypts of the small intestine where it could go and it can hide itself, okay, and it keeps on emerging through the portal vein. We always will have this problem. So we have to address something, okay, which actually finds that that research niche, okay, of that persistence of the virus, or any other cause. I'm open. I mean, data could prove it, but then we have to find the first ball, okay, which splits into 20 to 25 balls.
Yeah. Joachim, you wanted to make a point?
Very quickly on the antiviral properties of natural compounds, phenolic compounds. So if you ingest flavonoids or other phenolic compounds like curcumin, quercetin, they're all in the same class, more or less. They will be metabolized in the gut. That is the first thing that happens to them. They're primed a bit by the saliva, but once they go into the gut, they'll be metabolized. And many of them have very, very strong 3CL inhibition properties, to say something, against SARS-CoV-2. And so then you will have the maximum availability, so to speak, ground zero in the guts for these natural compounds. So very likely, and I will go and fly myself to Carlo and we'll try that.
Yeah. Listen, what we're going to do now is that we're going to formally close out. I don't know. I know Mike is not feeling well, so he may not be able to stay with us, but we're going to formally close. Anyone who can stay afterwards, please do, and we can continue to talk. Before we close out, I just wanted an opportunity to ask Valentina first and then Joachim, just to share a thought with regards to the vision or the idea of the long COVID coalition. What do you think, or what do you see where this could be? Go ahead, Valentina.
Thank you. So, first of all, we are facing so many challenges, and we see that medics and scientists are very much into a very small direction of their research field, and we are facing the disease, which is novel and needs collaboration between all medics and scientists in order to tackle it. And we already know that by many research papers and many interviews in the past, we agree now that this disease needs to be tackled by many experts in the field. Now, with the coalition, we think that it is wise to bring all these experts on the table and just basically analyze these issues and share thoughts on one or another research that basically would demonstrate today that we find some great experts and help them to share research findings and collaborate together with medics and potentially discuss treatments. Because what we do, we bring patient-centered approach. So we want to help patients suffering with long COVID and identify solutions that would tackle these main root causes of the disease. And if there are people in the audience who have got some thoughts on how to tackle, have got experience on natural solutions that would help us build these protocols to help long COVID sufferers, then please do get in touch with us. And we want to collaborate. We want long COVID advocacy groups to help us know the disease better, to listen to those patients who suffer with long COVID globally, as we do at the foundation. So everyone is welcome to collaborate within the coalition, but we all want to help people, not commercialize things, but we want to bring expertise together so that we can tackle this disease collaboratively, not from a single perspective.
Excellent. And I'll ask Joachim to just give a quick thought as well.
Yeah, I have very good news for all panelists today. So you're automatically now part of the long COVID coalition. I will share every new developments. And Philip, can you be so nice and share very quickly the slide I sent you with the wrap up that we tried to do before this meeting. And so this wrap up is now not, of course, finished. It is halfway through, and I will share that with everybody that was participating today to give their thoughts, because in order to be beneficial for each other in the collaboration and for the patients, we need to have the correct description of the pathway and the problem, the diagnostic tools, and the possible treatments. So if any of you is interested and have a good look at this, then fill in whatever you think is appropriate as a treatment or diagnostic tool, or if there needs to be more added. I tried to be throughout as far as I could have any prognosis how this meeting will go. So yeah, thank you for all new members of the Long COVID Coalition, and we will keep you informed, and the website will be up in the next days, and we will put each of yours presentation there if that isn't okay with you. And let's make this a living collaboration, so that it's not only just meeting and share some thoughts, but we have in between the possibility to connect with each other, share knowledge, share ideas and experiences in order to really make that a collaboration that is alive. Thank you, everybody, for participating.
Wonderful. Thank you. So I'm going to do our closing video for the audience. If you want to stay with us while we chat a little bit longer afterwards, please do. If any of the speakers or panelists can stay with us, that would be wonderful, but we understand if everybody has to go. So again, thank you very, very much, everyone, for this wonderful, inspiring, stimulating, educational conversation. And it has certainly opened my eyes to different routes and pathways that we have in front of us for long COVID. Thank you again, everyone. And thank you, everyone, for staying with us. And if you want to stay with us longer, you certainly can. Have a great evening, everyone.
Mike, you take care of your recovery.
Bye-bye.
Bye.